You know, a simple little puzzle can sometimes reveal two completely different ways of thinking. Today, we're going to look at one of the classics, the water jug problem, and see how an AI and a mathematician tackle it. It's pretty fascinating.
Okay, so here's the puzzle. I want you to think about this for a second. You've got two jugs, a 3-liter and a 5-liter. No other markings on them. You've got all the water you could ever want. How in the world do you measure out exactly 4 liters? Go on, pause and think about it. It's trickier than it sounds.
So, what are we allowed to do? Well, the rules are pretty straightforward. You can fill either jug all the way to the top, you can dump either jug out completely, and you can pour from one jug into the other. That's it. Those are your only moves.
All right, first up, let's look at how an AI would solve this. See, a computer doesn't have that aha moment of insight that we do. What it does have is raw processing power. So its strategy is basically to be super thorough.
The first thing an AI does is map out something called a state space. That sounds complicated, but it's really just a list of every single possible amount of water you could have in the jugs at any time. So we start at state 0, 0, right? Both jugs totally empty. Our goal is to find a path to any state that has a 4 in it.
And this is what that map actually looks like. It's this giant, sprawling web of possibilities. Every circle you see is a state, like 3, 0 or 0, 5, and every arrow is one of our moves: fill, empty, or pour. For the AI, this isn't a clever riddle, it's just a maze it has to navigate, from the start to the finish.
So how does it search this maze? It uses an algorithm. A common one is called breadth first search, or BFS for short. Basically, it starts at our 0, 0 state and explores outward in layers. It checks all the spots 1 move away, then all the spots 2 moves away, and so on. It's kind of slow and clunky, a total brute force approach, but it is guaranteed to find the shortest possible solution if one exists, because it leaves no stone unturned. So the AI's thought process is just a list of moves. It might go, okay, start at 0, 0, fill the 5-liter jug. Now we're at 0, 5, pour from the 5 into the 3. Now we're at 3, 2, empty the 3-liter jug, now 0, 2. It just keeps doing this step by logical step until eventually, bam, it finds a state like 3, 4, and it knows it solved the puzzle. It works for sure, but it's not exactly elegant, is it? Okay, now let's completely switch gears. Forget the step-by-step grind. Let's see how a mathematician looks at this. They're not interested in the how. They're interested in the if. They're looking for a shortcut, a cheat code, really.
And this is the fundamental difference, isn't it? The AI is asking, how do I get there? The mathematician is asking, is it even possible to get there? What if you could know for certain whether a solution exists without pouring a single drop of water? To pull this off, we need a simple math tool. It's called the greatest common divisor, or GCD. All it is the biggest number that divides perfectly into 2 other numbers. So like for 8 and 12, the numbers they share are 1, 2, and 4. The greatest of those is 4. That's the GCD. Simple as that.
And here is the magic trick. It's a mathematical fact that any amount you could possibly measure with 2 jugs has to be a multiple of the GCD of their sizes. This isn't just a rule for this puzzle, it's a fundamental property. It's the key that unlocks the whole thing.
Okay, so let's apply this amazing rule. Our jugs are 3 liters and 5 liters. What's the biggest number that goes into both 3 and 5? Well, it's just 1. So the GCD is 1. Our target amount is 4 liters. Is 4 a multiple of 1? Yeah, of course it is. And just like that, in one single step, the mathematician knows a solution is absolutely possible. No searching required.
So there you have it. 2 totally different paths that lead to the same answer. One approach is all about finding the specific steps, doing the work. The other is about stepping back and understanding the deep structure of the problem itself.
Let's just break that down. The AI's search is basically a how-to guide. The great thing about it is it gives you the literal step-by-step instructions, but man, is it inefficient. On the other hand, the math formula is more of a possibility check. Its superpower is speed. It tells you instantly if an answer exists. The downside? It doesn't tell you a single thing about how to actually get there. You know, there's a really great way to describe these 2 ways of thinking. The AI's method is a problem-solving approach. It's following a recipe to find an answer. The mathematician's method, that's a problem-modeling approach. They're building a simple, abstract model of the problem to understand its fundamental rules.
Okay, so who cares, right? It's just a fun little brain teaser. But here's the thing. This difference between problem solving and problem modeling, it shows up everywhere in some of the most important technologies we rely on every single day. I mean, really think about it. That AI's brute force search through a state space, that's basically how your GPS finds the fastest route to your destination. It's searching a giant map of streets and traffic. And the mathematician's elegant possibility check, that's used in huge logistics and optimization problems, like when a company needs to know if a shipping schedule is even possible before they waste time and money trying to plan it.
So this leads to a really interesting question for all of us. The next time you're stuck on a problem, which approach are you taking? Are you thinking like the AI, just trying one step after another, searching for that path? Or are you thinking like the mathematician, taking a step back and trying to understand the whole map of the problem itself? The truth is, both are incredibly useful. And knowing which one to use, well, that's the real puzzle.